Computer vision is formed on the basis of CNN, convolutional neural networks, which is an advanced type of neurals. We'll do some hands-on coding also to first. Human vision is what we see as humans when we look at people, when we look at objects. We can identify, hey, that's an apple, that's a TV, that's something else, right? Similarly, anything that can be seen from the eyes of a computer, it's a visual imagery, right? In simple words, computer vision is adding labels to visual imagery. Anything that can be seen and interpreted, that becomes computer vision. Somebody has taken a video, later you are analyzing the video, the sequences from the video, that can be one example. Then we are talking about multidimensional data. If you have gone to Dubai airport or somewhere, there are 3-4 cameras and it takes a 3D video or image of you guys. And then any image that is taken from your cameras, your phones, or even medical devices like MRIs and X-rays and all that scanning, that also is a part of computer vision, right? Just to give you a quick background, computer vision is about putting labels to visual imagery, right? So what is it that we can do with computer vision? So there are a lot of use cases, a lot of things we can do. We can do object detection, face recognition, video tracking, image restoration. That is, I hope you guys know what it means. There'll be some old photographs of your mom and dad or grandfather or something. It'll be kind of spoiled. So if we want to do restoration of that image, we can apply techniques for image restoration using CNN, computer vision and all. There's also, if you guys remember this video of Titanic or movies where Roman Empire is shown, where the Colosseum, which is completely destroyed, partially destroyed, that is reconstructed in gladiator type of movies. All these are reconstructions that can be done in computer vision. So today, one of the things we'll do is, if you see this image on the right side, I have created a small object detection program, which I will teach you guys how to do that. You should also be able to do that. Hardly 12 lines of code is there. We'll be using a library called YOLO. You only look once, not live once. And using that, you all should be able to write your own program to do object detection. Open your laptop, open the camera, and start moving around, and you will see all the objects, right? That's one of the intentions for today. So we'll first understand some concepts around this. How does computer vision work, right? So as you know, we talked about ANN, artificial neural networks, in the past, right? Which has an input layer, output layer, hidden layers, and all. Now, the whole point of using any neural networks is normal machine learning is all statistics and it does not think like a human. The idea was to mimic our human brain. So how do we achieve that, right? That's where your neural networks came into picture. So achieving human-like thinking, how does a human brain work? We have dendrites, we have neurons, we have signals. Imagine when you touch a hot plate or anything hot, immediately we take our hand back. How? Why does that happen? Because there is a signal that is sent to our brain from the point of touch, right? These neurons are kind of excited and the signals are passed, and the brain receives the message and it says, hey, it's hot, and then we retract our hand. Very similarly, the concept of this neurons, dendrites, and all is implemented in neural networks. Each of these small round green things that you're seeing, we call that neurons, and there are multiple of them, and each of them has a specific purpose. For computers, it's going to be more mathematical. The next part of computer vision is actually convolutional neural networks. It's a special type of neural networks. It is actually focusing more on only image processing, audio processing, videos, and all that stuff. And on top of convolutional neural networks, there are advanced libraries, which is built on top of CNNs. That is YOLO, your DLib. Many more are there, which I'll be showing you guys. I'll be talking about that. Yeah. So first, since you know a little bit about neural networks, let's understand how convolutional neural networks work, right? Or what is a CNN. So whenever we are training a neural network using CNN, your final network layers come in the end, right? That is the your neurons and the fully connected layers, what you've learned in ANN, will be at the end. But before that, we first take the given input images. For example, Sagar, I take 10 images of you, or Chirag, I take 15 images of you. I train a neural network by giving all these images, let's say even 100 images. If you use your Google Photos and all, that's what it does. What it does, the first picture it takes, it will apply something called as a convolution or a feature. If you see here the photo of Peter Dinklage, it has a filter called as edge detection applied, right? So I hope you guys have seen what edge detection is, right? In Photoshop or Snapchat or any other filter. You might have seen something like a edge detection or a blurring an image or any other converting from color to black and white, those kind of features you would have seen. So this is all done by applying something called as filters. It takes your image, which is, let's say, 100 by 100, 200 by 200, whatever size, it will convert to 48 by 48 or 32 by 32 as the image. Now each and every single pixel has the intensity. Now if it is black, the value of the intensity will be 0. If it is white, the value of the intensity will be 255. If it is gray, it will be somewhere in between 0 and 255. So every single pixel, this 48 by 48, which converts to 2300 and something, that many number of pixels, it will have different intensities, and that will be created as a matrix. And on top of that, it will apply a filter or kernel, or there are different words for it. It's very simple. It's nothing but a simple matrix of 5 by 5, 4 by 4, 6 by 6, or some dimension, which the neural networks will decide, the program will decide, and it will multiply the given image, which is converted to a matrix, and generate what is called as a feature map. So there are so many photographs. Continuously, it keeps applying multiple filters to each of them, which end up generating what is called as a feature maps. Now, one of the things that will happen is when there are so many images and it is applying so many filters, the number of input data or your images are going to just increase further, right? It's going to go even more. Now, to increase the efficiency and reduce the amount of data, we do a concept, something called as max pooling. So this max pooling is about multiplying the matrices, the feature maps, by into a 2 by 2 matrix. The idea is we are reducing the size. We are reducing the size of the feature map by half. So if it is 48 by 48, after max pooling, it will become 24 by 24. But all the features, important ones, that are retained. Anything that is not important, like for example, I have one picture of, let's say, Rakshita standing in front of a tree, and then another picture where she's standing in front of a bicycle. In both the pictures, Rakshita is still there, right? Or Chirag is in photo, he's going on a boat. Another picture, he's in a passport photograph or something that he's given. All of them, the only common things are the features of his face, his eyes, his nose, all that will be retained. Anything else, the motorbike or the bicycle or the tree or the boat, that is not required, that will all get removed. And that's how the most important features of a given person's photograph will be taken in. So you keep applying these feature maps, that is using convolutions, multiple number of times, and finally we get one more layer, which becomes a typical ANN type of a neural network, which is a fully connected layer, which means each neuron talks to the all the other neurons in the next layer. So by doing that, applying weights, multiplying, we finally get a set of numbers which identifies where does that belong to. To do classification, we apply an activation function, which is called as softmax function here, and the model gets trained. Every time it sees Sagar, it will be able to detect Sagar. Every time it sees Praveen, it will be able to detect Praveen's photograph. So that's how it works. I know this is something new, and some parts may look a little complex, but it's not as complex. If you write one code, first program, to do a convolutional neural networks, it's very easy. It's about 10 lines of code, 15 lines of code, where you say create an empty model or a network, and then add layer 1, which will be our convolutional layer, add another layer, which will be our max pooling layer, add another layer, which will be, so there's a dot add method for the layers, and you keep adding it, and your neural network gets ready. Then you take one folder, put all your images, run the program, and it gets trained. A lot of things happen internally, because neural networks, we don't want to go deep inside and understand what it is doing, right? If I play a guessing game with you guys, I'll say, we played this game last time with somebody, where I said, I'm keeping one number, can you please guess it? So Chirag guessed it as 88. I said it's very high. So he next number he guessed was 22, right? Why did he guess 22? So that is his brain. If I ask the same question to Sagar, he may choose a number 24, right? He has his own way of reducing the number when I say it's very high. But the internals, that deep, we don't have to worry about. But the process is what something you need to understand. Yeah? So by using convolutional neural networks, which is a special type of neural network, we are feeding in a lot of images during training. The program keeps going pixel by pixel continuously and starts identifying the features. So again, when I said features, when we as humans, when we look at features, we look at it things very differently, right? For example, I was having this conversation with some of you guys recently, Abhiram and others. How do you explain a car, right? So as humans, we look at a car and we start explaining it, saying, okay, there are four wheels, there is a windshield, there are four doors, there are two seats in the front, two seats in the back, there is a steering wheel, there is a top, so many features, right? So that's how we look at as parts of a car as humans. But if you ask the same question to a computer or a software or a neural network, how does it look at a car? It is not going to understand what's a wheel, what's a bonnet, what's a windshield, right? So the only way it will understand, probably, I'm just guessing, it could be anything. It only understands numbers ultimately. So it may use some mathematics, some geometry, some shapes. For example, windshield can be a rectangle or a trapezium or a, your wheels are all concentric circles. Maybe each wheel is like six concentric circles with the hub, with the exterior of the tire and the interior of the tire, and so many, I mean, not edge of the tires. So basically, a circle is a pi r square, right? So similarly, length into breadth or length into breadth into height. So it could be just formulas and numbers that it will detect and identify. Ultimately, it's all numbers and vectors and embeddings that it gets converted and stores. But we don't have to worry about that. The idea is, if when it sees, let's say, eyebrows, right, all the single small hair strands on in the eyebrows, they're all next to each other, but your forehead, your skin around the eyes, they're all in a different color. Immediately it will be able to distinguish the color density difference or the pixel density difference. That's how it will be able to put a edge detection or make things blur just by doing matrix multiplications. So the idea, I hope this is clear, and hope you guys are getting the concept. I don't want you to learn everything in 5 minutes, 10 minutes. It takes time to digest, but the idea is, this is how it starts identifying features. It's going to start breaking down each of the different parts of the face as a different features: your eyebrows, your eyes, your nose, your lips, your hair. But that's exactly not how it will detect. It will have its own way of identifying the patterns in the face. So that's how the architecture of convolutional neural networks looks at. And like I was telling about the convolutional operation itself, right? Here's an image of a cat. Now, if the cat's image is taken into, let's say, 28 by 28 or 48 by 48 image, then we convert all the intensity numbers into a matrix of numbers. Then when we apply one of the filters, let's say something like edge detection, you can see the output here. This is how it is looking. It is able to identify the eyes, the ears, the body shape, the legs, and everything, and it has left out a lot of other details. But it is going to be able to identify it is a cat, because the model will be continuously trained on so many images of cats. It will be able to extract all these independent features. Like I was talking about a car and the images and parts, you can see we as humans identify there is a door, there is a second door, there's a window, there is tire 1, tire 2, all the parts that we can see. There are also some parts that we cannot see, but what we see is what we get generally. So that is convolutional operation. So now, where is computer vision in general applied, right? We know computer vision is very popular. If you are applying for a job, there are computer vision engineers. This alone in your AI journey can help you get jobs. You don't even have to learn many other things like LLMs or NLP. Just pure computer vision alone can get you jobs. So how and where it is applied, right? If you start looking at the examples, then you'll say, wow, it's really pervasive. It is so many places it's being used now, right? In transportation industry, people are using it for autonomous driving, self-driving cars. It will be able to detect your stop sign, red lights, people in the road, a cow in the road in India, for example, right? So so many things are it's able to detect, identify, and make sure there is no accidents or collisions. Even there is this use case we worked on called drowsiness detection, which is a driver of a van or a car, school bus is carrying kids, but previous night he has made a journey to some trip, like let's say a Shimoga trip or something, right? And very tired. What will happen? It will be very risky for the life of the kids, right? So using computer vision, the camera inside the dash of a car can actually detect if the person is drowsy, the yawning is happening, or the eyes are slowly closing and opening. Immediately it will send a beep beep message to the supervisor or make some sound and wakes up the person. So we are preventing some big hazardous accidents. Hospitality, not hospital, even healthcare it's there, but hospitality is about your airports, your restaurants, hotels, where computer vision is used heavily. In fact, some of the projects I have worked on, which is terrorism detection and racism detection, heavily it uses all the computer vision models like emotion. Like a person, for example, air hostess was not very friendly to certain ethnicities and races and colors, versus some specific people from certain countries, they were very pally and friendly and treating them nice with a good smile. Racism detection project was able to identify if there was a bias, if there was some kind of a discrimination, and it would identify and show, mention it to the supervisor, and they could train their personnel better. So we have a better industry there. Manufacturing for surface defect detection, or your uh, what do you call that, paint, dent, scratch images and all that stuff. So those kind of things is used in manufacturing. Then healthcare industry, we use for x-rays, covid-19, you guys know all that, I guess, right? So so much of computer vision is being used. So then there is banks, your whole KYC, know your customer, face detection, or uploading your documents, your whole, what do you call it, Aadhaar card or any other, it'll be done using computer vision. Insurance for claims, when people do a building roof fell down, immediately you can take a picture or a video and send it and gets approved automatically. All those things have become made things industries very very fast. Human resources, your attendance management, how many hours a person has been in the office, outside the office, smoking, going out, coming back, all that can be easily detected with computers. I know it's not a great use case. People are going to be pretty unhappy about it. It's like, hey, even I was there in the office for 8 hours, but it showed me only I was there for 5 hours, 5.5 hours, right? But yeah, technology improves. There are the good and the bads. What can I say? So we talked about various different use cases, right? One of the important one is object recognition, and we will be doing some coding for this. It's a very small program, so very easy to do. I'll give you some background around this, and that way you will be able to understand. So object recognition is all about, I mean, object detection, object recognition is all about identifying objects through the camera, right? So there are many steps that happens here. So first thing is about image classification. That's a pure CNN, convolutional neural network, right? So when you look at an image, inside the image there are multiple images. So the first one that it looks at, it's going to say whether it's a cat or a dog or a car or bus. The CNN will be able to identify that, okay, this object is this. That's all. It won't do anything. It'll just identify and keep quiet. The actual next step is going to be what's called as localization. Localization is the process of drawing a box. So it sees a cat, then it puts a box around that, right? Then actual object detection is also the labeling. On top of it, it will put a label that this is a cat, this is a dog, that's a bench, this is a, if you can see this image on the left side, you can see there is a labeling of each of those objects that was detected, and there was a localized box that was put around it. Then even more interesting, nowadays it's getting better and better, that's segmentation. So there are again two types of segmentation. One is instant segmentation, another one is semantic segmentation. So instant segmentation, I mean, there's, it's just names, don't worry too much about the keywords and all. So instant segmentation is just every single instance, like if there are 5 or 6 dogs, each of those dogs are shown in a different color. It is segmenting or separating each of the dog by putting it in a different color, and completely around the dog it is showing a colored thing. Yeah, so that becomes each instance having its own segment is instant segmentation. So there is also semantic segmentation. So this picture will tell you what that semantic segmentation is all about. Yeah. So in the left side you see a dog, and then there is also 3 sheep, right? When you apply semantic segmentation, do you notice what happened here? Yeah. So the dog is in red color, but all the 3 sheep, they're all in the same color, that is blue. It's not like one is red and one is blue. Like, see, in instant segmentation, you can see one of the dog is in blue, one is in pink, one is in green. But in semantic segmentation, all the sheep are in the same color, because the CNN detected every time it looked at one of these objects, it said, oh, this is a sheep, I identify. They all belong to the same class. So it tried to do it as a semantic segmentation. So these are the concepts around how objects are recognized, and we'll be implementing that using many architectures. Again, I have put only few, like 5 or 6 architecture names here, but trust me, there's at least 30 or 40 or more than 100 different solutions, architectures. There is ResNet, there is so many others that I have not mentioned here. But these are very important, very popular, and people use this a lot. So the first one is VGGNet. This is very beautiful and deep convolutional neural network. When I say deep, it just does not have 3 or 4 layers. It has hundreds of layers, thousands of layers maybe. It has millions of input parameters. That is the neurons where everything gets split. So when we talk about emotion detection, about being happy or sad or angry, all that can be very subtle, right? For example, somebody is grinning, somebody is smiling, somebody is angry, somebody is serious. The face is the same, the eyes are the same, the nose is the same, the hair is the same, your forehead is the same, chin is the same. The only small difference is in the movement of the lip, and probably a little bit of contraction of the eyes or expansion of the eye, or like your dilation or whatever you call it, right? So with that much of a subtle difference, your model still has to make sure and identify that, hey, this is a smile and this is a angry and this is serious, right? So that's why deep networks like VGGNet will be useful. There are also RCNN, YOLO, HAR Cascade, MTCNN is there. Also there is UNet, very popular ones. I've used many of these, most of these, actually all of these, in one or the other projects, and they're all very cool, very easy to implement, not very difficult. Yeah. So YOLO is something we will look at today. What do you think is the full form of YOLO? Zindagi na milegi dobara. You only live once. No, it's actually very close. It is you only look once, right? So the idea is the previous versions of CNNs were pretty slow. It would take a lot of time looking at every single pixel, going through again and again. So YOLO tried to do very quick look at it once and tell me what you already see, right? It'll be a with a lower accuracy bad, then look at it again, or start identifying objects. So it's very fast, it's pretty optimized, it's pretty good. We'll look at that. There's also UNet, which we use for segmentation, especially if you have done BG remover, background removal features and all. UNet seems like a pretty good thing. We had done for one of the restaurant images, which worked pretty well. So your HAR Cascade, MTCNN are also pretty good for object detection. And yeah, we'll look at that. So again, today we'll be doing this program. I just tried this a few days back just to check. When you implement the code that we will do today, you'll be able to do exact same output you will get. You'll be very happy to see the outcome actually. It feels very powerful, and it's like, wow, can I do a program like this? Can I do a program like this? It start feeling like that. It's identifying a chair, a person, a bottle, a cell phone. A couple of other people are also there. It'll be pretty good. Yeah. So now I talked about major architectures, right? In this, we looked at YOLO. Well, today we'll be implementing a YOLO-based object detection, and YOLO, as I mentioned, you only look once. There are multiple versions, V1, V2, V3, and it's always improving. YOLO V5 probably was one of the extremely good ones that stayed for a very long time. We did use it in so many of our projects. I think the Sprava third eye project, which we worked on, which has AI smart glasses for the blind people, visually impaired, that was all YOLO V5 for currency detection, object detections. Then there came YOLO V7, YOLO V8. Now there's YOLO V9. Also YOLO V11 is getting released or already released. Yeah, I think it's already there. They're all pretty good. You guys should explore one or the other once you learn this. So what are we doing in today's coding session, right? This is it. This is all the code you will have to do today. If you look at the number of lines, just 10 lines, but it is extremely powerful. One of the beauties of using a programming language like Python is you can import any library, you can integrate any library into it very easily. Many libraries are there, thousands or millions of libraries are available, and it's quite good. What we are doing here is importing your YOLO model from Ultralytics. That's the first line. From Ultralytics, import YOLO. Then we are importing OpenCV. That's an open source framework for computer vision. That's called CV2. Then we are loading the models, which is the model mainly, YOLO V8. N is for nano. There is a small, like you get t-shirts, right? Like you get small, large, extra large, XXL, double XL. Like that we have nano, small, medium, large and all. For the sake of trying out, N is okay. If you're putting it into some production with high great servers and all, you can go for larger models also, but it's the same, the logic is the same, it's just the slight accuracy differences will be there, right? So in the code, what we're doing webcam detection. For that, CV2 library has a very simple method called video capture. Again, the bracket 0 means which camera. If I have 2 or 3 cameras, I can say 0, 1, 2, like my laptop's webcam versus a connected third-party web camera, all that we can choose. And then just opening a endless loop while cap.e is open. As long as the camera is on, keep doing this, right? Read each and every frame, assign it to the frame, then model of frame, right? Results is equal to model. What is model? Model is your YOLO V8. So model of frame will give you the result. Then we are just plotting the results, which means it draws a bounding box. All that is very easy. With respect to cv2.im show, that opens up a window. I don't have to open a browser. I don't have to use Streamlit or Django or React or nothing. You can see the result live in your laptop Python. Cap.release will release the video stream and closes. For this, there will be a if condition. If you see here, if cv2.wait key q. So if somebody, like if I press the q, it will break, come out of the loop, and then releases the whole video capture. So that's explaining what the code is. So we were talking about YOLO. Mainly, it is designed for real-time objects. One good thing about YOLO, your CNN will detect always only one image, one object at a time, right? But YOLO will detect multiple objects also. If you see this image here, there is a man, there is a horse, there is a dog, right? When you apply the YOLO, it resized the image, it ran a CNN, detected individual objects, then it did your bounding boxes, that is localization, and then it also put the labels, which is object detection, and it also separated out the bounding boxes, and we have our YOLO model outcome. Yeah. So there is also other libraries like DLib, which is one of the very beautiful libraries for face recognition, especially. So it has something called as 68 key points on the face, which it's called as facial landmarks. So if you look at these dots, right, any face, it will try to map these numbers. So these numbers shape can differ. Like somebody's eyebrows will be slightly straighter, somebody's will be very curved, somebody's nose is thick, somebody's nose is thin. Doesn't matter how it is, right? So it will start putting these points exactly on, like if somebody has a bigger mouth, smaller mouth, the points will be at the two ends of the mouth and the curvature of the lips and all that stuff. So eyes, nose, mouth, eyebrows, this all these forms a 68 point. Yeah. So there are very use cases. I was talking about drowsiness detection, where the actual thing happened. A bus driver hit because he was drowsy, and the kids got injured. Some people got killed. People got hospitalized. That can be pretty dangerous, and computer vision can help. So let's actually go back to our YOLO and do some code. Uh, Give me one moment, please. Yeah. I hope you guys can see my screen. Yeah. All right. So this is the code that is commented, and this is the code that is uncommented. The only reason I'm showing this is to let you know that it's only 12 lines of code. Today you guys can actually write this code even now live. It's what, like 4:30, 10 minutes we will be done with the code. I want you to try this, and I will show you how to do this. First, you guys want to see the outcome? Let's do that. Yeah, I'm going to say Python space obj, sorry, det. Oh, I don't know if my screen will be shown. Let me check. Let me just try that. Give me one moment. I'm waiting for it to run. Yeah, it's still running. Okay, I think it started running. Now I can see myself. I don't know about you guys. Let's just give me 1 second. Okay. Window capture. All right, let's see. I hope you guys can see this now. Yes. Yeah, it is showing, it has detected a person. I'm going to show a remote control. Yes, it says it's a remote. I'll try and show my cell phone. There's too much. Yeah, it did say it's a cell phone. Let me grab my laptop and see if I can show that. Yeah, it says it's a laptop. I hope you guys can see it. It's a very simple code. I just ran it and it seems to be working. I'll type Q and it should stop. Yeah, it did stop. Do you guys want to try it? Try the code? Okay, let's go through that. Yeah, I hope you guys can see my screen still. Okay, what's the first step? It is import the YOLO class from the Ultralytics package for object detection. Should I paste this code in the chat window? Let me see. Yeah, whoever is interested, please try this code. Next is import CV2. Let me give all these 3 lines. Yeah. Is anybody trying? Just message me if you're able to do it. Also, before even running, let me give the code. There are some things that you have to do, and I want you guys to do that right now. Oh, there is a limit. Okay, let's do this. Yeah. Okay, the very first thing you have to do is, okay, none of these files matter, so please don't worry about it. There is requirements.txt, right? You have to create a file called requirements.txt, and there you have to put only these 3 lines: Ultralytics, OpenCV, Python, NumPy. If you want, you can give the version numbers. If not, your current Python should take care of the most appropriate ones. I'll anyway give that. So if you do this and then say pip install -r requirements.txt, and I run this. So this is going to get all these. It says requirement already satisfied because I have already installed it. But if you have not done it, you could uh, just do that, and it will say, it will go and pick up Ultralytics, install it locally. It will go to your library, OpenCV Python library, pick up the installable binaries, install it locally on your machine, and it'll also install NumPy. Another thing I do is I always create a virtual environment. So it's quite easy. First you have to say Python -m and then give the environment name, like for example CTO-env. That's not there. I'll just give test env, right? and then you have to switch to that environment, right? Yeah, it'll take some time because has to create that environment. Just give it a moment. Oh, yeah, while it is doing. Can you guys all try that too, please? Yeah. Anybody wants to try it out? It's right there, hands on. You will be walking away with, hey, I did object detection today. So please try that out. Yeah. Okay, it is done. Then how do I activate that environment? If you're on Windows, there is a command, and if you're on Mac, it's a slightly different, but it's very similar, right? So what is the name of the folder I created? Test.env, right? Test.env backslash scripts backslash activate, right? Now I'm in test environment. Now I do not have all these files, so I'm going to say pip install -r requirements.txt. It's going to bring all these libraries and install it. Yeah, it's collecting ultralytics, and then it will collect OpenCV, then it will collect all the NumPy one by one, and some of these SciPy, Torch, all that's already there, so it is using the cached one which is already there. There are many internal small libraries that it needs, and then it's doing all of that. This is going to take some time, so let's understand the code. What did we do? What are we trying to do here? So first is import the YOLO library. That is, you only look once library, which is used for object detection. It has so much of inbuilt functionality. That's a very beautiful one. Then you do computer vision, CV to OpenCV, import CV2. Then, like I said, we are loading YOLO V8N using this class method called YOLO. That's the name, which is imported from YOLO. So I'm creating a variable called model. It can be X, A, Y, whatever. I call it model. Then, like I said, you're opening the camera. That's what happened earlier. And then first thing we did was read a frame from the camera. Then Boolean indicating if the frame was read successfully, that's what is the RET. It'll show 0, 1 or some error message. Then the frame is the actual image frame. Like continuously, if you're watching a video, every single split second is a frame. But that frame is being passed. Now, then what we're doing, we are processing the frame through the YOLO model. Like I said, this model variable is actually the YOLO object method, right? We are loading the frame to it and then catching the results into this, right? And then we want the bounding boxes. The results.plot will give X and Y coordinates, length and height of the image, and it will draw the box around it. This cv2.im show is what the image that popped up and that showed. So let me know who all has tried it or trying it, and if you are able to get any results, you can type it in the comments. If not now, if you want to do it later, you can, but it's as simple and easy as that. Yeah, this is still taking time to install, so don't worry about that. So yeah, that's just to recap, right, what we talked today. Let me go to the beginning. Sorry. Yeah. So we are trying to understand all the aspects of computer vision. We saw a video about terrorism detection and racism detection in the airports and how things happened. And then we tried to understand what computer vision is, putting labels across images, visual imagery. Like humans have human vision, computers have computer vision, right? Like from X-rays, MRIs, and all that stuff. So we talked about what are the use cases, object detection, face recognition, video tracking, all that stuff. Then we tried to understand how neural networks, CNNs, contribute towards computer vision, and finally the advanced libraries and mimicking the human brain. We talked about the convolutional neural network as the architecture. We can go deep into it. I have a video which I have released related to computer vision, which talks all about computer convolutional neural network. It explains what max pooling is. It explains what your convolutions are of feature maps. What are the filters that it puts? How it applies the softmax function and gets the classification. All that is explained in the video on one of my YouTube channel. On my YouTube channel. And yeah, we looked at the convolutional filters, and each of the way a human versus a computer understands an image. Yeah, so we were talking about different industries. Let me go to some of the other use cases that probably we did not talk about. Yeah. So there is transport, drowsiness detection. So if you look at this here, how does a drowsiness detection actually work? Right? In this picture, you see that the person is yawning, means the mouth is wide open. So immediately it triggers in the architecture that, hey, I found something different. This guy had his mouth shut all the time. Suddenly he's opening his mouth, and that will trigger, oh, sorry, one second. Yeah, that will trigger that something has changed, and the object detection or the localization will say that he's yawning. So yawning becomes true. Now your rest of the drowsiness detection program will start getting alert. It will start seeing eye blinking rates. Right? Look at this person. He's so drowsy. He's not able to hold the eyes. It is falling. Oh, sorry. I don't know if you're able to see my presentation. Yeah, sorry about that. Yeah, I hope it's visible now. The presentation, not so sure. Yeah, okay. I think the presentation is now visible. Sorry about that. So yeah, let me go back. We are saying drowsiness detection. Then a person is yawning, the face, it's detecting the yawn. Then if you look at the second video here, we also trained a lot of our videos from the client who had given us drowsiness pictures. But this is a sample where a person is really, really sleepy. The eyes are shutting and he is trying very hard to open it. And the blinking rate will immediately tell that, oh, this person's really, really sleepy and drowsy. And it starts making a beep beep sound on the device. It will send a message to the supervisor. You can see the body language, the steering control, everything is a problem. We were talking about autonomous driving, where you can look at this image. You can see that there's a person standing on the street, and this is the actual live image. On the right corner, you see there's a person in a black coat. He's moving his hand and telling, wait, don't come, let the bus go. Or he's telling, okay, you first go, then let the bus go. He's trying to do some traffic management on his own. But if you look at the top side here, it's all these colorful violet and pink and red or different colored. It is showing the same objects. This is how IR or computer related devices will start seeing. And then you look at the plot here. This is even difficult for a human to understand, but the computers easily understand. You can vaguely see the partial head, the movement of the hand. Hand is just a line, the other hand is to the side, and there's a plotting going on. And it is able to detect that there's a person standing. So this is a self-driving car, right? The self-driving car is able to detect that the person is there, and he is asking you to stop, and it has stopped automatically. There is no need for a driver to be looking at it. Yeah. So then we talked about hospitality industry, where there is racism detection, terrorism detection, many more things. How do we do that? Whether the greeting, there was a disgust, loathing, where the smile was a fake smile or a real smile. Then for terrorism detection, there is a trained database of USPTO or something like terrorist faces are all known terrorists are all documented there. So we train the model. We let the model know that these are all the terrorist identified people, and whenever that person, even they are clean shaven and haircut is done and in a nice suit as a businessman, fake passport, they cannot escape the computer vision. It will still be able to identify and detect that this is a. So there is also dangerous object. Somebody is holding a gun or a knife. We saw that in the video. It will immediately detect, alert. So even that split second early decision can change or save lives. Right? Unattended baggage is a big problem. We have implemented unattended baggages using some of our architectures, and it's working very well. Nervousness, it was all AlexNet, VGGNet. So again, racism detection, like I said, there's fake smiles. Fake smile was a big problem for us in one of the projects we worked on. When the air hostesses or the ground crew were told that you cannot discriminate, you have to smile. So some of the folks started doing a fake smile. That also became a problem. Yeah. So the fake smile is not natural. If you see, I'm smiling right now, and even my eyes contract. And also after smiling, if I want to make a serious face, it's going to take a few seconds, right? It's not going to be immediate. But with a fake smile, it's just the lips that have gone to the sides, but your eyes have not changed, or they come back to normal immediately. So all these were used for training the your fake smile detection, and that was pretty good. Disgust and loathing was immediately identified. There's a younger person coming, and the air hostess is greeting with a smile. There's a elder person coming here, and there is no greeting. These are all some cases that we have seen, and this was the whole terrorism detection project, which was an amazing project. These were taken from the database. We were able to identify this is the person who was a terrorist, cut his hair, wore glasses, wore formals and suit, and nobody could say it is the same person, right? Only computer vision was able to identify, and we tried that. Yeah. So yeah, we yeah, there's also anomaly detection. For this, we use something called as convolutional LSTM. Suddenly, if something happens in an airport, like a bomb threat or something, people start running in full speed. All that's all not natural or not normal. Or there's a suspicious-looking person moving around. That can also all be identified by your anomaly detection logic. What it does is it uses CNN along with something called as LSTM, long short-term memory, and both combined, it will continuously keep on a method. Yeah. So yeah, let us I think that's probably it for today. uh, so guys, can I make using C++, Aman? Yeah, definitely. You can also, there are many libraries that's available in C++ also. You can definitely use that. I think there are DLib itself is a C++ library, so if you know that. So we actually put a wrapper on DLib in Python and then use that. So definitely, yes, you can use that. Okay, guys, I'll leave a couple of minutes for questions if anybody has any questions. I see most of them were, and I hope it was useful. Were you guys able to understand the concepts, whatever I was trying to explain? I think there's a lag, so okay. All right, guys. Uh, Thank you so much, and I will. Oh, what happened? Okay. All right. Thank you, everyone. Hope you guys have a good day, and we will connect soon. You guys can message me on even WhatsApp or our AIML community. I will be answering that. So, what is it with numbers that appears above the bounding boxes? Oh, yeah, that's a great question. It is the probability of the class. So, what is the percentage? I am confident that it is a cat. I am 82% confident that it is a cat. So, which is equal to 0.82. Yeah. Yeah. Can you make using C++? Oh, I thought I answered that question. DLib is